Solving a quadratic inequality starts off similarly to solving a quadratic equation. You're going to want to set it equal to 0 and solve. But what you do afterwards is what sets it apart from solving just an equation. What you're going to do is you're going to make a thing called a sign graph to see what is true and what is false. The area or areas that are true will be your solution. Just make sure that your final answer is written in interval notation. So first we have the inequality x minus 5, x plus 2 is greater than or equal to 0. So it's already factored for us, which makes life easier. So we're going to set each one of these individually equal to 0. So x minus 5 equals 0 and x plus 2 equals 0. So add 5 over, x equals 5, subtract 2 over, x equals negative 2. So we have our two answers so far, but that's just what we're going to be using for our sign graph. And the sign graph is going to look like this, kind of like a number line. So put it in order, negative 2, positive 5. Then from here, I'm going to pick some test points. Something to the left of negative 2, which I'll say is negative 3. In between negative 2 and 5, I'll say 0. And something greater than 5, I'll say 6. So now I'm going to take each one of these test points, plug it back into my original inequality, and see what's true and see what's false. So start off with negative 3. So negative 3 minus 5, negative 3 plus 2, greater than or equal to 0. Going to get negative 8, negative 1, and that's going to give me positive 8. So is positive 8 greater than or equal to 0? Indeed it is. So that means everything in this area where negative 3 is true. Now I'm going to do it again for 0. So 0 minus 5, 0 plus 2, greater than or equal to 0. So I'm going to get negative 5, positive 2, and multiply those together to get negative 10. So is negative 10 greater than or equal to 0? No, that's false. So everywhere there's 0 between these two, this area, is false. Now I'm going to do 6. So 6 minus 5, 6 plus 2, and 6 minus 5 is 1, 6 plus 2 is 8, and then 1 times 8 is 8. So is 8 greater than or equal to 0? That is true. So it means the area where 6 is true. That means the whole area is true. So I now have two areas that are true over here and over here. So my final answer is going to be, since it goes all the way to negative infinity up to negative 2. And since it is equal to here, greater than or equal to, use a bracket. Then a union, and then I pick up 5, and again, greater than or equal to, so I use a bracket again. And it goes off towards infinity, so off towards infinity. And so this will be my solution to this quadratic inequality. Next, x squared plus 5x plus 4 is less than 0. It is not factored this time, so we're going to have to do a little bit of work to begin. So we're just going to factor this, and it's not too bad. It's just going to end up coming out as x plus 4, x plus 1. And now that it's factored, put it in each one equal to 0. So x plus 4 equals 0. X plus 1 equals 0. Now solve. Subtract the 4 over. X equals negative 4. Subtract 1 over. X equals negative 1. Not too bad. Again, make my sign graph here. So negative 4, -1. And again, I'm going to pick some test points. So something to the left of -4, which will be -5. Something in between -4 and -1. I'll say -2. And something greater than -1. I'm going to use 0 because 0 typically gets rid of things. So just like we did before, we're going to take each test point and plug it back into the inequality. I can do the original one I started off with, or I can do the factored form that I got. Either one will work, but I'm going to do the factored form because I think it's just easier. So -5 plus 4, -5 plus 1, less than 0. So I'm going to get -1, -4, that's not equal to, and then multiply those together, -1 and -4, I get +4. So is 4 less than 0? No, it's not. So big ol' X in that entire area. Now I'm going to do -2. So -2 plus 4, -2 plus 1, less than 0. So I'm going to get +2 here, -1 here, and then I'll multiply these two together and I'm going to get -2. And I ask, is -2 less than 0? And it is. All is well, so that means everything in this area is good. And finally, I'm going to plug 0 in. So 0 plus 4, 0 plus 1, less than 0. So I'm going to end up getting a 4 here, getting a 1 here, and then I multiply those together and I get 4. So again, is 4 less than 0? Obviously not, since we did it before. It's false. So everything in this area is false. So this time I only have one true area between -4 and +1. So put it over here. So from -4 to -1, and we had less than, but not equal to. So we're going to use parentheses here around our numbers for our answer. And here is the solution to this quadratic inequality.